Alright, so I think I'm recording. I don't want to jinx myself, but my last video worked out great. I didn't have to make two of them. So I don't know if that makes you happy or not, but it does me because I've been doing the same problem over and over again several times and recording it and not getting a recording. Okay, let's take a look at problem number 11. Now, unfortunately, this is not in vertex form. I've seen from my previous problems when it's in vertex form, that vertex is the crucial point on a parabola. It it defines where that axis of symmetry is. It tells us if it's opening upward, the y coordinate tells us the minimum of the function. If it's opening downward, it tells the maximum. So I need to rewrite this in vertex form. We've seen that. The last one, this number 10, was not in vertex form. We had to complete the square. Whereas problem number 9, it was in vertex form, and I could just look at it and say, hey, the vertex is 4, 12. So let's come back here. We need to complete the square. And this one's even a little bit more challenging than the previous one, because I think on our previous one we completed the square, the leading coefficient was 1, and this leading coefficient is a -2. So this one is a little bit tougher. Let's come in, focus our attention on the first two terms. I need the coefficient in front of x squared to be a +1. So I'm going to factor out a -2 from both of these terms. -2, which now makes this the one that I wanted, because -2 times +1 is -2, so I haven't changed the problem. I need a +4 here, so when I factor out a -2, I need that to be -2. So if you distribute this negative to both terms, you'll get what we started from. So all I've done is factor it, and we have the same problem. The +6, and of course x greater than 1 is coming along for the ride. Well, now comes a little bit of the tricky part. I need this binomial to be a trinomial. I need 3 terms. And I need to be clever in how I make it 3 terms. The technique tells us to take half of this middle term and square it. Half of -2, when I square it, half of -2 is -1, and when I square that, it's a +1. But I did not just add 1 on the right-hand side, because this multiplier, because this -2 multiplies everything in the parentheses. Even though it looks like I wrote +1, when you take that +1 times the -2, I just subtracted 2 from the left-hand side of the equation, or excuse me, from the right-hand side of the equation. And I'm not allowed to just arbitrarily do that. But if I've subtracted 2, what if I come around and turn around on the same side and add 2? I have balanced the equation, only I've balanced it on the same side. If you have the x equals 1, if I add 5 and then turn around and subtract 5, then guess what? X still equals 1. Now, before, when we were solving equations, when we had something like x equals 1 and we added 5, to balance the equation, we said, well, let's add 5 on the other side. Add the same amount to both sides. But if I add some amount to this side and then do the opposite on the same side, turn around and subtract it, hey, that's balancing the equation too, because it cancels. If it's on the same side of the equation and opposite sides, it's going to cancel. If it's on opposite sides of the equation but the same sign, it's going to cancel. Now remember that I get lazy and I don't continue to write x greater than or equal to 1, but that's coming along with each equation. So now I'm ready to write this in vertex form. This trinomial, we added just the right amount So half of that was negative 1, remember, so that this is x minus 1 squared. And the 6 plus 2, why, that's 8. Okay? And this x is greater than or equal to 1. So let's think about what this graph looks like. The parent function is x squared. The minus 1 is actually a shift to the right 1 unit. When I go to the outside, that 2 is a vertical stretch, and the negative reflects it across the x-axis. So if I stretch this by a factor of 2, it becomes skinnier. And with the negative sign, I turn around and reflect it. Instead of opening upward, it opens downward. And then we lift it up 8 units. So in a different color, if this point, this vertex, goes up 8 units and it's opening downward, my graph is looking like that. Well, what's the vertex? It's 1, 8. The domain that they're restricting, they want points on this graph that the x-coordinates are greater than or equal to 1. The points on the left of 1, those x-coordinates, those points on this graph, are smaller than 1. So we come in and we say we want this portion of the graph. Let's try to erase this all these others. What's in green is what we want. Alright. This was my x-axis. This is this guy was 1/8. We wanted greater than 1 and it was opening downward. Okay. Sorry about all that. Alright, from looking at this graph, can you tell me what the range is? Say yes, sir. All of these points have a y-coordinate that's smaller than 8. So I know that all of these y values are less than, and the vertex, the y value is actually equal to 8. It's less than or equal to 8. Okay? Since this graph passes my horizontal line test, I know that the inverse is going to be a function, and furthermore, it's going to be a 1-to-1 function. Let's come in, rewrite our equation using just x and y. The technique for finding the equation for the inverse, well, we know that the idea of the inverse switches the domain and range. So in my equation, I switch the variables. Everywhere I see a y, I write x. Everywhere I see x, I write y, including my inequalities that describe my domain and range. X greater than or equal to 1 is now y greater than or equal to 1, and y less than or equal to 8 is now x less than or equal to 8. So this equation, we want to get y by itself. Right now, on the right-hand side, the first term contains the y, and it's not by itself at all. I need to subtract 8 to begin to try and get it by itself. So first, I'll subtract 8. So now, this is negative 2 times the quantity y minus 1 squared. I see two factors here. One of the factors is negative 2. The other factor has my variable of interest. I'm going to divide both sides by negative 2, and I'm getting closer and closer to getting that y by itself. I'm going to write the y minus 1 squared on the left, and this fraction x minus 8 over 2 on the right. Well, we've seen it before. If you have an exponent of 2 and you want to get rid of an exponent of 2, get rid of the squared, you take the square root. to balance the equation, I have to take the square root of the other side. Because of the definition of square root, because we're taking the square root of a variable, that introduces a plus or minus into my equation. On the left hand side, this exponent of 2, I can now just write this as y minus 1. And so I have this. The plus or minus is just shorthand notation that really this is 2 equations. I'm going to now split that up and write it as 2 equations, but here we'll add 1 to both sides, so we'll get the y by itself. So I have y equals 1, and I'll pick the minus x minus 8 over 2. And the other equation, or y is equal to 1 plus, because this plus or minus that was in front of the radical, over here in front of the radical is minus, over here in front of the radical is positive. Now, let's not forget that we had these restrictions coming along for the ride as well. Y greater than or equal to 1 and x less than or equal to 8. It's the y greater than or equal to 1 that has me, that interests me, because both of these equations have been solved for y. And I want both of these equations, the y's, to be bigger than or equal to 1. Over here, this is a subtraction problem. I have 1 minus, and what I'm taking away is always a positive quantity. So 1 minus something that's positive is taking that 1 value and making it smaller. I need it to be bigger than or equal to 1. Over here, on the right-hand side with this equation, I'm adding some positive amount to 1, so that 1 is increasing. It's getting bigger as we pick different x's that you're allowed to take the square root, different x's where x is less than or equal to 8. If it was, oh, wait a minute, did I make a sign error? I'll have to think about that in just a second. Y greater than or equal to 1, I'm going to pick this one. Now, I need to pause the video for a second because I'm surprised over here to see that x is less than 8. If I had something that was less than 8, like 7, 7 minus 8 is a negative number. So I need it to, and I'm not going to make you watch that. I'm going to double check and see if I've made an error here, and if it's a type of error that I can come back and explain, or unfortunately if it's a type of error where I have to do this video over again. So it's not going to seem like I paused it, but I'm going to pause it for a minute. Be right back.